Hey, welcome back. Today we're going to talk about centripetal force, weight, and friction. Today you're going to learn about how centripetal force acts through friction and how the centripetal force of friction allows a vehicle to stay on the road. We're going to use these for examples. These examples could be used in other situations as well. Okay, on roads it is friction that allows or provides the centripetal force to keep a car on the highway around a turn. So let's say we've got this car and it's going to be traveling around this turn. Well, here is the center of the turn. So what force is keeping or pulling the vehicle towards the center of the turn? Because we decided or learned yesterday that there has to be this centripetal force to cause an object to make that turn. And what it is then is this centripetal force is equal to the force of friction between the tires and the road. So it is the force of friction that is providing that centripetal force. So what we find out in our sum of forces equation, in this case sum of centripetal forces is equal to the force of friction. So we would say mv squared over r would be equal to mu n in this case. Okay, so here's our first example. An 1,800 kilogram NASCAR is traveling around a 300 meter radius turn at 100 meters per second. So we've got this NASCAR. It's going around this turn. So somewhere on here. Alright, so here's my picture. Here's a tire, there's a tire, there's a tire. So I'm looking at it from the top view. It says find the centripetal force. So we want to find this centripetal force that's pulling it towards the inside. Well, our centripetal force then is equal to what is supplying this centripetal force? Well, it's friction between the tires and the road. Well, our centripetal force equation is mv squared over r. So as I start to work this out, the mass they tell us is it's 1,800 kilograms. The velocity is it's going 100 meters per second. It's moving. That's really fast. And the radius is 300 meters. What that gives us then is a centripetal force of 60,000 newtons. Number 2, find the friction component pushing towards the middle. So what is the force of friction? Well, that's a concept. Let's go right back up here. For number 2, whatever the centripetal force is, the centripetal force is being provided 100% by the force of friction. So this right here is our force of friction as well. Then it says find the coefficient of friction. So I'm going to say 60,000 equals mu times n. But I'm going to replace n over here by mass times gravity. The mass is 1,800. Gravity is 9.8. And I'm going to keep it positive because the normal's pointing up. So our normal then in this case is 17,640 newtons. So I'm going to put that over here for the n. Divide both sides by 17,640. The mu in this case then is 3.4. Now, I was just chuckling when I got that answer Because then once I saw it, I realized what it was saying, and we'll see if one of you guys can come into class tomorrow and tell me what the problem is with that. I'll give you a hint. This is why racetracks are embanked if they want them to go fast around turns. And 100 meters per second is probably about 220 miles per hour. Okay, in this problem here, a 2,500 kilogram vehicle is on a 250 meter radius turn. The road has a coefficient of 0.6. Find the frictional centripetal force pulling on the car. So I'm going to do that over here. Step 1. The sum of the forces is going to be, the only force that's pulling on the car is the force